Hello everyone, welcome to my YouTube channel. This is Naveshriyan from Sri Venkateshwara College of Engineering. So I'm going to explain about the insertion sort with algorithm steps and efficiency and topological sorting with the two types and its graph. So introduction to the insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted array, one item at a time. It is efficient for small data sets or nearly sorted data. The algorithm is stable and in place, meaning it does not require any extra space. So algorithm steps of insertion sort. Start with the second element and compare it with the first element. If the second element is smaller, swap the position, repeat the subsequent elements.
Today we're going to learn insertion sort. Let's dive right in. We're given this array and we want it sorted in increasing order. Here's what we're going to do. We'll start at the left and work our way to the right, examining each item and comparing it to the items on its left. We'll then insert it in the correct position in the array. You'll notice that part of our array will be sorted as we progress. We'll mark those items with a green background. Let's begin and you'll see what I mean. We start at 2. Of course, there are no items to the left of 2, so we mark it as sorted. Moving on to 8, we compare it to 2 and leave it where it is. Our first 2 items are now sorted. Next we have 5, which we can see is out of place. We know it needs to be after 2, so we swap it with 8. Our first 3 items are now sorted. On to 3. Again, it's out of place. We swap it with 8 and 5 until it's in the correct position. We're at our 5th item, 9, and I'm sure you can see that it's in the correct spot. Let's move to 4 and insert it in the correct place in the array. And that's it, we're done. Insertion sort is one of the most straightforward sorting algorithms. For your reference, here's the pseudocode. Insertion sort has the worst case time complexity of big O of n squared, where n is the size of the array. For example, when an array starts in decreasing order, you need to swap and compare every single item, which leads to big O of n squared. Thank you for watching. I'd love it if you subscribe. Please post suggestions for future videos below.
So starting the second element is the 5, first element is the 9. So compare it with the first element. 5 should compare with the 9. If we compare 5, it is lesser than the 9, so we should swap the elements. So here first element will become the 5 and second element will become the 9, and again the third element should come. Again this 9 and the 4, it is compared, and 4 will be the third element, 9 will be the fourth element, and again 9 and 3 will be compared. 9 will be the last element and the 3 will be the third element. Again the process will be keep on continuing until unless the sorted elements are in a order. So efficiency of the insertion sort. So the best time complexity of big O of n when the array is already sorted. So the average and the worst case time complexity is big O of n to the power of 2 due to the nested loops. As the space complexity is big O of 1, as it does not require any additional space. So introduction to the topological sorting. Topological sorting, it is a linear ordering of a vertices in a directed acyclic graph. So it is used in a project scheduling, task sequencing, and dependency resolution. Two main types of the Khan's algorithm and the depth first search DFS algorithm. Here, a topological sort algorithm A, B, C, D. If we are going to delete A in this A, B, C, D, E, A will be disconnected or removed, and B, C, E will be in the diagram. So Khan's algorithm for the topological sorting. Initialize a QU With the vertices that have no incoming edges, remove the vertex from the queue, add it to the topological order, and remove its outgoing edges. So repeat it until all vertices are processed. DFS, depth first search algorithm for the topological sorting. Perform a DFS traversal starting from any perform a DFS traversal starting from any vertex. Add the vertex to the topological order after visiting all its adjacent vertices. So reverse the order to get the final topological sort. Example of a directed acyclic graph. So DAG is a graph with the directed edges and the no cycles. Vertices represent the tasks or the nodes. So and the edges represents a dependencies. Topological sorting can be applied to determine the order of the task. Topological sorting graph. In the graph, vertices are represented by the circles and directed edges are represented by the arrows. So the graph shows a dependencies between the tasks or the nodes. So topological sorting helps in determining the correct order of a task to be executed. Application of the insertion sort and topological sort. Insertion sort can be used for the sorting small data sets efficiently. So topological sorting is essential in the project management for the task scheduling and the dependency resolution. So both algorithms play a crucial role in organizing, organizing and optimizing processes. So the conclusion, insertion sort is a simple and efficient sorting algorithm for a small data sets. A topological sorting provides a linear ordering of a vertices in a DAG. Understanding these algorithms that can enhance the problem solving skills and optimize the workflows. Thank you.